5, 4, 3, 2, 1, 0.
There's no denying that rockets are pretty cool, but there's also no denying that rocket science is a little bit intimidating. But don't worry, because in these next few videos, we're going to learn that it doesn't have to be that intimidating. So buckle in and let's get ready for liftoff. Hey everyone, my name is Sid, and welcome to the first video of this series on rocket science. Today we're going to be talking about propulsion, which is basically how rockets are powered. It's how you get a rocket from here to there. So the most fundamental concepts of propulsion can be explained using two pretty simple physical concepts: Newton's third law and the law of conservation of momentum. So Newton's third law states that if object 1 exerts a force on object 2, object 2 will exert an equal and opposite force back on object 1. So if my hand pushes against a wall with a certain force, the wall will push back on me with the same amount of force. So let's try looking at it from that perspective. So when you see a rocket, you see all of that hot, fiery exhaust gas coming out from the nozzle. So the force of the rocket pushing all of that exhaust gas downwards causes the exhaust gas to push the rocket upwards with the same amount of force. This is what we call thrust, and it's what allows rockets to lift up into space. Airplanes rely on a similar concept. So we can also look at this from the perspective of momentum. So basically, momentum describes an object's motion. It's the product of its mass and velocity. So we can see that an object with a greater mass traveling at a higher velocity has more momentum than an object with less mass traveling at a lower velocity. The law of conservation of momentum states that the total momentum of a system will remain constant, as long as no outside forces are acting on the system. So let's look at conservation of momentum in action. You can imagine that the skateboard is the rocket, the weights are the propellant, and I'm the astronaut. Now watch what happens when I throw the weights to the right.
4, 3, 2, 1, 0. All engine running.
The system's initial momentum is 0, so in order to compensate for the rightward momentum of the weights, the skateboard and I move to the left, keeping the net momentum still equal to 0. So if we look at a system with the rocket and the propellant and ignore outside forces such as air resistance, we'll see that the net momentum of the system is 0 initially when the rocket is at rest, and the momentum will remain constant throughout. The rocket moves upwards with a positive momentum in order to balance out the downwards or negative momentum of the propellant, keeping the net momentum equal to 0. Now, I've been talking a lot about all this fiery exhaust gas coming out of the rocket engine, but you're probably wondering how that actually happens. Well, let's talk about it. Now, every rocket carries propellant. So the propellant is made up of a fuel, such as liquid hydrogen, and an oxidizer, such as liquid oxygen. So just like when you light a candle, a similar process occurs. The wax acts as the fuel. After you light the wick, the wax melts and is absorbed by the wick. When the wax is brought up to the flame, it reacts with the oxygen in the air, resulting in a combustion reaction. Now when mixed together and ignited, the fuel and the oxidizer combust and go boom. So after all this happens inside of the combustion chamber, the hot gas is then pushed out through the nozzle, providing that force of thrust that we talked about earlier. This is what allows the rocket to go straight on up. Now, normal aircraft also use this combustion process for propulsion through their jet engines. But here's an important note. Normal aircraft don't have to carry an oxidizer because they're traveling in the air, which already has oxygen in it. They just need the fuel. But spacecrafts, when they're in space, can't use the air as an oxidizer because there is no air. Because of this, they have to carry the oxidizer and the fuel together as propellant. So if you look at the space shuttle, you'll see that big orange tank is just full of propellant. And that brings us to another question. How much propellant do you actually need to get a rocket into space? If you want to find out, join me next time where we're going to be talking about the ideal rocket equation and so many more cool things. If you like this video, please give it a like and subscribe to the channel for more videos just like this. Thanks for watching. See you soon.